Hello all, welcome to my channel. I'm back with another video, and in this video we will be looking at how we can speed up Flink using a native engine. So there is a trend going on in data engineering field that we are looking at native engines as an acceleration point for certain engines, certain computations that we have. For example, in Spark we have Gluten plus VERA-X as an accelerator. We have Data Fusion Comet as another executor, which all rely on the native execution engine. Similarly, in Flink, we also have JVM-based concept, which can be modeled on the same way that we do it for Spark. That how we can speed up the execution of Flink. So this article is majorly will be talking about VERA-X, which is a new product from VERA. So just a disclaimer, this is my understanding as well that VERA-X is based on top of Flash. So Alibaba Group was working on a project called Flash, which is nothing but a native engine for Flink, but they also acquired Verberica, and then Verberica launched a product called VERA-X, and also in their documentation they have used the common terms. So I believe that it is either inspired by Flash or it is built on top of Flash itself. So I will be using Flash and VERA-X interchangeably. So what happens in this case is the native engine part that comes into Flink is uh, based on certain optimizations that they have done. Uh, so first thing is that native this engine processes data in highly efficient batches. So instead of, for example, let's say if we are processing data, let's say 1 lakh transactions per second. This is Flink throughput. So what it does, instead of processing row by row, what they do is they create a batch of 1,000 records. So if we are processing larger, there is some introduction of slight delay that rows are not directly getting processed, but it also helps us in doing the same thing faster in a resource constrained environment as well. Then also it uses a forest DB, which is a state management system. This is called for streaming DB. This is state heavy streaming jobs that they have implemented. And it is a simple Flink integration because they don't have any breaking API changes. This works with any API that any Flink written earlier as well. There is no breaking change in that, and it also has a UDF support. So how they have built this system is this is similar to what other engines also do. So they have a layer called Deno, which is nothing but a similar. You can think of it like as a gluten in case of Spark. So Spark plus gluten plus Velox. That is the analogy that I will be using. So Flink generates a plan, and that gets handed over to Leno, which is their native plan generator. It will generate based on this plan which was created by Flink. It will generate a native plan, and then if that is supported, that this engine supports that, it will go this route. If does not support, it will go to the Flink Java runtime route as it is fallback mechanism. So once it is, let's say it generates a native plan which is supported for that particular operator, then there are two things. One is Flash native runtime, which is Falcon, their engine name, which is an async vectorized streaming operator and execution platform, which is written in C++. That's where the native part comes. And then the state is handled by Forest DB, which is Forest Streaming DB, and it has two modes. One is Mini and one is Pro. Mini is for small and Pro is for async on disk storage. Mini is for in-memory storage, and Pro is for the disk one. And see the layer wise. So API layer same as Flink. Then we have Leno layer, which is the plan translator, a native plan translator. So it will convert a Flink plan to a native plan, and then it will have a Falcon engine, which is a vectorized operator layer. Okay, and then Forest DB for state management. So this is the flow or the architecture of this VERA-X platform, which or Flash, which does a native runtime acceleration for Flink. The blue components are the ones which are open source Flink framework, and then orange ones are the ones which are added by the native runtime kernel. So these ones, Leno, Falcon, ForestDB are something that. And fallback support for Flink Java runtime is there. So if the operator is not supported by this yeah, engine, it will fall back to Java. The core design is there. There are three layers: Leno layer, which is integration layer; Falcon operator layer, which is vectorized computation layer; and Forest DB for an storage layer. So if you see SQL table API, it will pass through the Flink planner. Flink planner will hand it over to Leno. It will generate a plan. Then it will pass it to the native runtime engine, and then it will execute those things in the native operator. And if the operators are not supported, it will fall back to the Java runtime, which was there. So again, as I mentioned, Leno is similar to Gluten or Spark, and it will leverage, it will create a plan, which is native plan, and it will hand it over to the C++ engine. Falcon, it uses C++ vectorization. Again, it uses SIMD for data parallelism, and also this is where I was talking that okay, how it is consuming, how it is you leveraging the batch part. Like, and let's say if we have an upstream node which processes batches of 10,000 roughly 32 KB and transmit as a network buffer. Downstream processing also occurs in batches of 1,000 records. The specific batch size for processing these 1,000 records, such as 10, or depends on the algorithm that or the characters that we have. Then it is for a streaming DB, their vectorized storage system is that okay, instead of creating a very large state in memory, they can be handed over to the pro part, which is on the local disk or the OSS. There is also an engine for maintaining the state on an external location rather than the Flink engine. So the Forest DB Mini is an in-memory state store, and Forest DB Pro is it uses LSM and it offloads the data in memory from the disk, and then we can leverage that disk as a state. So this is the throughput improvement that they are gaining is 5 to 10x throughput improvement compared to the open source Flink. Latency also has single digit millisecond latency under heavy stateful workloads, and the total infrastructure cost was lower, 50% lower cost due to better CPU license and vectorized state. There is another project called Iron Tools, which is on based on data fusion, which is not an open source. VERA-X is also not open source. It is a Fabrica platform. This also is not an open source project. It's an proprietary product from one guy who was working maybe earlier at with Flink a lot, and then he found that okay, we can do this similar to what Spark, Gluten, and Data Fusion Comet was implemented. He also tried to implement this for Flink using the data fusion layer itself. So this was it. This was a quick bite that I wanted to share with you guys. Thanks for watching this. If you like it, do share it and keep rocking.